In this video we're going to take care of creating a custom component, and so we're going to be here in package symbol, but instead of using the wizard we just use the regular package symbol. So we're just going to call this custom, and then it just creates a blank slate for us. Now one of the things I want to do first is set up some design parameters, and the one I want to do is I want to change this back to mils, and then I'm going to click apply to that to make sure it's changed back to a mils, and then I will go ahead, and this is setting up the window. This is under design. Yours might already be on mils, and what I'm doing here right now is defining the lower left hand corner and the upper right hand corner of our design, meaning that I can't have anything bigger. Essentially it can't be any bigger than 4.5 inches by 4.5 inches, because 1,000 mils is an inch. So it's plenty big here for us. We won't need all that space. It's fine that we have it. I'm going to turn my grids on. I'm also going to set my grids up here. I'm going to set them so that the spacing is, for the non-etch, is 1 and 1. Now that's going to create a lot more dots there. That's fine. I still find it easier when I'm working on these things to have those there. And then I'm going to click on OK. Now some people don't like to have all those dots. Actually that's a little too much here. I'll go design parameter. Let's just do 10 mils in both direction. Yeah, that's a little bit better. So we can still see here's my origin. That's where my little 0, 0 is. And if you hover over, you can see at the bottom of the screen it gives you the coordinates. And by doing the 10, 10, it's just snapping every 10. By doing it 1, of course, you can go every 1 millimeter. But we're actually going to be doing a lot of things command line, so we're not going to necessarily need to worry about some of that. Alright, so let's go ahead and dive into getting our custom footprint. So I need to pull up here the actual schematic, and this is what we're going to be creating custom footprint as, and this is the actual component here. So this would be a through-hole mount component for an AC plug adapter. Alright, now some CAD drawings for components are nice because they have this little PCB layout, which we're actually going to use here. And then notice that it says the units are in millimeters. Now we have it in mils here. Now as far as the pinholes, that doesn't matter, but as far as these dimensions, we're going to have to convert these to millimeters. Now there's online calculators that can do this, so millimeters to mils, and you might say, why don't we just put everything in millimeters? I've found that cadence doesn't work very well always in millimeters, so I do a lot of things in mils, but if you had wanted to do everything in millimeters, that would be fine as well. I'm just going through having to do it in mils as a conversion. So the first dimension though that I'm going to want to convert, and I'm going to make some notes here, is notice that these right here, these 3 holes on this CAD drawing, of course, refer to these 3 pins. And then we've got 2 mounting holes here, and this refers to the diameter as 1.8 millimeters, and this diameter is 3.5, and then the distance between these holes is 7 millimeters. So I'm going to do 7 millimeters, and that is equal to 275.591 thousandths of an inch. So just go ahead and round that, and I'm going to just round it to 276. If you're off by 1 mil, it's not going to make a difference in your actual layout of your footprint. Okay, so then we're going to go back to here, and the first thing we're going to do is we're going to place those pins. Now I'm going to go ahead and place one of those pins at the origin, and I'm going to just go ahead and place, well, let's go back to the drawing. It doesn't really matter which one you place at the origin, so let's go ahead and place this pin right here at the origin. And so we'll do the left pin at the origin, and then we'll place the other 2. Now what's nice about this is that there is a way that you can place all 3 pins at once. So first off, we're going to go to Tools, Layout, Pins. Now there's a copy mode, and we're going to take advantage of this copy mode. First off, we have to select a pad stack. Now, I don't have the 100% appropriate pad stack here because I've got one that's 1.8 millimeters with a 3.58 etch around it. And we said in previous videos that really, if it's a 1.8 millimeter diameter hole, you really should be looking at doing like a 2 millimeter, drill that we're doing on it. But right, 1.8 is fine at 3.5. So I'm going to click on OK. This is my pad stack. And it shows up here. It's pretty big. That's because I've got zoomed in. Maybe I'll increase my grid spacing even a little bit more. But then before I place that pin at 0, 0, I'm going to say I need 3 of those in the X direction, and I'm going to go to the right. So that means I'm going to start on the left, move to the right, and then the spacing of these, well, it was 276 mils. So it's going to place 3 pins, and it's going to put them 276 mils apart, each one of them. Now, I could go here and try and get my mouse to go exactly to 0, 0 and then click the left mouse button like I have it now. But I find an easier thing is to actually go to the command line and to actually place something. Now that we're trying to place something, I do X for placing, and then I do the X coordinate space Y coordinate. So I'm going to do X, 0, 0, and then you hit enter. And you can see it's placed that pin there, but then it's, as I said, it's placed 3 of them. 1, 2, 3, right next to each other. And then I'm going to hit escape, or I'm sorry, right click and then done to say I'm done placing my pins. Now you'll also notice that it does give you numbers here, 1, 2, and 3. You can actually go through and change the colors on it, but what's important is to notice that 1, 2, and 3, these pins labeled left to right. And the reason that's important is that in your footprint here, if I go back to the mechanical drawing, if I'm thinking of this pin being 1, 2, 3, pin 1 is the neutral, pin 2 is earth, and then the line is pin 3. So that's important to know, of course, that whatever pins here you have in your footprint have to match the pin descriptions in Cadence. And when we actually go back to creating a layout in Cadence, we'll review that as well. Alright, so then what we need to do is we need to go back here. I'm going to go ahead and zoom out a little bit. This doesn't look like I've got this correct. Oh yeah, this is fine. So I'm just keep zooming out and in for some reason. Alright, the next thing I'm going to do is on this PCB layout here is these are these mounting holes. These are 3.5 millimeter mounting holes. And I said that 1.8 wasn't okay. I did actually misspeak here. 1.8, when it has a PCB layout, that's actually the recommended drill hole size. If you notice here, the actual pitch of this pin is 1.2. So we actually have plenty of space for us. So when you have a PCB layout like this, it's actually telling you the size of the holes you should drill, 1.8 millimeters. And then this should be a 3.5 millimeter hole. Now what should we notice here? That 3.5 millimeter hole is going to be located 7.3 millimeters above the 0, and then we'll have to figure out what it's going to be to the left of the 0. But we know the spacing is 39.5, so let's do that conversion here. 39.5 is 1555 mils, so I'm writing that down. And then let's go ahead and figure out what this dimension here is. Well, it's pretty clear that I would do 39.5 minus 14 and then divide that quantity by 2. And that's going to give you that distance here. So let's go ahead and pull up a calculator to do that. So, and I'll pull it over here. So 39.5 minus 14, divide that by 2, and we get 12.75 millimeters. So I'm going to again convert that to mils, and that is 502 mils. So I'm again writing that down because I'm going to go back now to my drawing here. Well, maybe. There we go, back to my drawing. And now what I'm going to do is I'm going to lay out pins again. but this is now says it's a connect pin. What I want to do is a mechanical pin. A mechanical pin is basically a mounting hole. And so I'm going to pull up, and I actually have specific mounting holes that I have. And mounting holes make it so that you don't actually have to have copper etch around them. And so there's actually a special type of mounting hole, and I'm going to select the 3.5 mounting hole. And then I'm going to still do a copy mode, but you have to be careful. You want to make sure you change your copy mode or turn it off. So I'm going to do a copy mode 2, and notice that they were 1,555 mils apart. Now I need to place it. Well, 0, 0 was where this first pin was, and if I already got this distance as 502, and then we know that this distance, oh, we forgot to convert 7.3 to mils. So let's do that. 7.3 is 287 mils. And then we go back to this here. And so what I'm going to do is the x value is minus 502, because I want to go to the left of 0, and then positive 287. And there I have those mounting holes placed now. Then I do done again, and I've got my mounting holes. So I'm going to go ahead and save this. It's going to give me some errors because I don't have everything done. It's like symbol is missing, ref des, create symbol has been aborted, but it still has saved this file. So I've still saved what I've worked on so far, but the reason it basically is saying I can't create the part yet because you're missing some things. Alright, the next thing we need to do here is actually create the geometry of the package. And this is where, depending on the device you're creating, you can be very precise or, you know, somewhat lenient. And I would say in this case I'm going to be somewhat lenient, because essentially when you're talking about a package here, you might want to at least give some idea of the shape of the package, but ultimately you're trying to make sure that you have a rectangle or something so that you know don't place anything inside this rectangle as far as components or things like that, because that's part of your part. And so what I like to do here is I'm just going to take a dimensions here. It's 50 millimeters, maybe we consider that long, and then if we look here at this one here, we can see it's 1619. I'll just even round that to 20 millimeters wide. Okay, so let's convert those to mils. So I'm going to do 20, which is 787, and then I'm going to also do 50, which is 1968. And we'll round it to 1969. Alright, back to the software. And so what I'm going to do here is I'm going to say a packaged geometry, and I'm going to do place bound top. And basically what this place bound top is, that means this is the boundary of the component. Now, I know this component's not exactly a rectangle, but I'm still going to use a rectangle just for easiest sake. Now, if you wanted to use something else, you could actually do line segments and create kind of your own little polygon, which we'll do in a second here. But for now, I'm going to just create a rectangle. And it says it's package geometry, and it's on the bound top. And I could draw the rectangle, or instead, I'm going to place the rectangle. And let me first off zoom this over a little bit here so we can see everything that's going on. So here's the dimensions of the rectangle. So the width here, now we have to pick the right number. That's going to be the bigger one, 1969. And then the height here is going to be the 287. Wait, it's not 287, it was 787. And you can see, hey, I've got this nice little box here. Now, we want to make sure this is somewhat accurate of it, and what we can see here is, if we go back to this diagram here, we can see that we're definitely centered here. And so we can go ahead and do the place command and place it. Now the thing is if we try to do the XY coordinates, we have to find the top left corner of this. So if we look at this, again, 50 mils, we could figure out what this distance is right here. And if we wanted to do that, let's go ahead and do that. So this would be 50 minus 14. Where's my calculator? 50 minus 14 divided by 2, which is 18 millimeters. And then let's convert that to mils, so that's 709. And then we can see, well, wait a minute, these pins are almost at the edge of that width of that component anyway. And actually the width here says it's gives you several different ones. I'm using the 20 approximate here. So I'm not going to be too concerned about that one. I'm going to basically place that at what equivalent would be 19 millimeters. I'm sorry, 19? No, what I'm going to do here is place it at, yeah, 19. And so 19 millimeters to mils is 748. Alright, so then let's go back to our drawing here. And I'm going to place this, because this is in reference to the 0, so x is going to be negative 709, and then the y value is 748. And then I have my bound box here. Now you might say, hey, these pins are located outside of the bound box. It's okay, it doesn't matter if they are or not. The reason they are located outside of that is because, oops, I just moved it. Let me undo that move. Is because I went ahead and placed it at 19. And these pins are really at the edge of the component anyway. And so the fact that the etch part is laying out of the component is fine, but you can see the holes here are right at the edge of the component. So the last thing you can do here, which again it's not necessary to do, but if you want to have some kind of illustration of what this looks like, we can go ahead and say, okay, silkscreen top or assembly top. We'll go ahead and do assembly top here. And we could go ahead, and I'm going to kind of skip this because you can go ahead and try and do all of the computations, but I'm just going to go ahead and kind of draw in roughly this little shape here that we had for this component here, you know, and then you know, right there and done. You know, so that's kind of roughly the shape of the plug. You can be more precise with it, and in a lot of cases you need to be more precise, but for what we're doing here and for most components you can get away with being a little cheap. But if you're ever doing this in industry, precision is going to be the key, you know. But for classroom experience we can get away with being a little bit on the cheat side there. Alright, so we have that assembly top. The other thing you might want to include is a silkscreen. A silkscreen is something that gets printed on the circuit board, so if you ever see something like R2 or things like that, that's printed on it. Now, you want to make sure you have some line width here, so I'm going to do a line width of 5. And you can silkscreen whatever you want, but I'm going to silkscreen essentially the same thing here. And just kind of roughly silkscreen it. Now when I drew these at when I do these lines normally on parts, I actually go through and do all the measurements and everything of that nature and then use the command line. And the way you can do that, just as a side note, I'll show you here how you can do some things with this. I'm going to put it off to the spot here, so I've got a line selected and I'm going to say X. I'm going to start at negative 1000, negative 1000, and then you can see, okay, well, I've got a line there started now. Now this is kind of a cool command. I can do IX, which stands for increment X. So I'm going to increment X 500. Then it draws a line 500 long here. And then I could say increment X or increment Y 100. And then I could say increment X minus 5. And it doesn't really show that here very well. Let's do another increment X of minus 100. Okay, there we go. And then let's do an increment X minus 100, increment Y 100. And then you get a diagonal line. So that's how I actually create those components here, but the video is getting a little long, and so I didn't want to spend the entire time doing it. But you can get very accurate ones by doing those increment commands. So let me just delete this. Alright, we still have one other thing. If we try and save this again, okay, we'll save it. We're still going to get an error. It says ref_des missing. And that's you need a reference designator. And so you want to do ref_des and assembly top for your ref_des. And this is where you're going to use the font here. And why is it not there? Oh, there we go. Sorry. And I'm reminding myself here. Yeah. See, the text block lets you control the size of the text. Okay? So what we're going to do here is this ref_des we're going to first put up here, and 7's pretty big, so I would maybe do a 4. And this is where you type in a description of this, and so maybe I'll say this is a jumper or J, but this is where you really want to use what this referred to as the star business here, because what will happen is if you have many components like this being placed, it will say J1, J2, J3, J4, so on. It automatically appends whatever numbers associated with this part from Cadence, from Capture. And so I'll go ahead and say done. But before I do that, I'm also going to do a silkscreen top. And sometimes you can put it in the same spot here. And then I'm going to do the same thing here and J star, because that will then be, again, the text that's printed. Now, when you're doing your layouts of these, you'll be able to move those around if you want to. But this will now put on both the assembly top and also a silkscreen, and you can hover over to see what they are. Now go ahead and click save, and it's going to say overwrite, and we don't get any error. So we've actually finally created this footprint, and now this footprint could be used in Capture to create a layout.